Hi, Algebra 2 students. Here we are in Chapter 11. We're looking at Section 11.7, the Binomial Theorem. So our vocabulary consists of some terms that I'm pretty sure you guys are familiar with. Maybe not binomial theorem. We're going to really talk about that today. But Pascal's Triangle for sure and factorials. What is Pascal's Triangle? So it is this triangle made up of numbers, and it's kind of fun to play with. It starts off with 1. It has all ones on the outside. And so it's 1 and then 1 and then 1. And then to get to the next line, you put 1, 2, 1. Where's that 2 coming from? Well, we're adding up the numbers that are on either side and above the number that we want. But remember, we always start with 1. So what would this next number be? 1 plus 2 is 3. 2 plus 1 is 3. And don't forget your 1. Let's do it again. 1, start off with 1. 1 plus 3 is 4. 3 plus 3 is 6, 3 plus 1 is 4, and 1. Again, 1. You bored in class, this would be a fun thing to do. Just do this. Make the triangle as long as you want to see how far you can go. 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then we get a 1 again. And you can do this for a long time, like forever, literally, but probably it'll get really jumbled and look funny. Cool things about Pascal's triangle, like we did this, but look, 1, 2, 3, 4, 5, and it goes on like that. And so you see really neat little patterns. That wasn't that incredible. I think these are triangle numbers, 1, 3, 6, 10, like numbers if you could do 1, 3, 6, you know what I mean? Triangle numbers, 10 would be 1, 2, 3, 4, 1, 2, 3, 1, 2. Triangle numbers, nobody? Anybody? Okay, fine. So there's all these little neat little patterns. If you make like hockey sticks in it, I forget something happens. Go to like YouTube and watch a video because I'm sure somebody made an awesome video about Pascal's triangle. Beautiful. What does it have to do with our lesson? Well, we're going to use this to talk about binomial expansion. And we're going to see some really neat relationships that happen. Matter of fact, I might tell you in a minute. So we'll get there. So that's Pascal's triangle. The other thing we need to talk about is the binomial theorem. And it's a little bit hard to talk about. And if you were to like look it up on the internet, there's like several different ways that it can be written. Our textbook chooses a way that I'm not like super fond of, but we're going to talk about it, and we're going to talk about the way that you'll see it on the internet that I kind of think is a little bit more concise. But before we talk about that, we actually have to know what a factorial is. Anybody remember? I'm looking around the classroom and you're waving your hand, and I would say speak, but I can't hear you. So factorial, it's when we have like this little exclamation point next to a number, and what it really means is take that number, and you only do it with positive integers. 3 times 2 times 1 is what that means. So you take the positive integer, you multiply it by all of the preceding integers, and you stop at 1, because if you multiply it by 0, it would just be 0, right? Right. Okay. So 3 factorial is 6. Just a little reminder. I know somebody's there like, I know this already. Why is she telling us? Because we need to know. 4 times 3 times 2 times 1 is going to be 24. And basically you could be like, oh, you should have just said 4 times 6, right? Because 3 times 2 times 1 is the last factorial. And it goes on forever and ever, and it's beautiful and fun. The reason why we wanted to review that is so the binomial expansion theorem can make sense. So a quick Google search of the binomial expansion theorem will bring up some really horrific and mathy looking things. And I say that because, you know when you're watching a movie and like math is happening, like these are usually the pictures that you see, just like lots of stuff going on. I'm going to attempt to use this formula to explain, even though our text will use several different formulas, but I'm going to wait to do that until later. What I'm going to explain about the binomial expansion theorem is that what we're trying to do. And you also saw, by the way, back here, did you not see there was like a picture of Pascal's triangle? What are you doing there? So let's talk about it. So you know what the word binomial means. It means a number or variable, an expression that has 2 different variables that can't really be simplified. And so if I were to raise a plus b to the 0 power, I would get 1, right? I would get 1, and that's fine. If I were to do a plus b to the first power, I wouldn't get 11, but the coefficient would be 1a plus 1b. And so that's what that represents. So it'll make a little bit better sense when we do this. What about a plus b to the second power? If you have forgotten, we do FOIL method, and we get a squared plus 2ab plus b squared. And what you notice is that the coefficients are 1, 2, and 1, and you see what we're talking about. And so what's happening is we can use the Pascal's triangle in order to get or determine what happens when we expand our binomial to different powers. So what I'm saying is that when I FOIL this, when I multiply these guys together, I'm going to get this. I'm going to get a to the third power plus 3a squared b plus 3a to the first power b squared plus b to the third power. Like, that's legitimately what's going to happen. And you can see very nicely that the coefficients are there. So how are we using this? How is this helpful for us? Well, what we can do is therefore say, oh, well, this is not too hard to figure out. The coefficients are there. All we need to do is figure out the pattern of the exponents, and we've got ourselves a good deal. This can give us an opportunity or an easier way to expand many things, many different types of binomials without actually having to go through and multiply, which would be a pain in the butt, right? So that's why this is cool. Let's think about what's happening with the exponents. Notice we had 2 A's here. Now we've got an A and a B, and then 2 B's here. And here we've got 3 A's, we've got 2 A's and a B, an A and 2 B's, and then 3 B's. It looks like the A is descending while the B is ascending. So the first variable descends in power. It will take on the power, the first variable, the power of the actual that the actual binomial is being raised to, and then we're going to make sure that each term has that degree. Okay, so you remember that a degree is the sum of all the exponents of a term. So this is a third degree term because 2 plus 1 is 3, 1 plus 2 is 3. You guys with me? So let's see if we can expand this thing again. So now I'm going to try to do I prefer red here, a plus b to the fourth power. You know, we're on this row of Pascal's triangle. It would be a to the fourth plus, so that's 1a to the fourth. Let me put the 1 in there. 1a to the fourth plus 4. Now remember what we said about a, it's going to diminish. So a to the third, and then we're going to have b to the first. That keeps this a fourth degree term, plus 6. I'm choosing like a different green each time. I'm trying, guys. A to the second, b to the second. A diminishes, b increases, plus 4a to the first, wrong color. I'll get there, guys. You know we will. A to the first, b to the third, and then finally plus 1b to the fourth. Thank you guys for being patient with this. This was far more difficult than you realize. Okay, so this is what we're using. So we're using this to figure out how to expand. Now this is cute, it's good, it's helpful, but it's not always cooperative. And so what the binomial expansion theorem is going to do is give us a way to do it without using the Pascal's triangle. And we'll get into that in our lesson. Thank you guys for being patient. Let's go ahead and see what we can get into. So for this first example, we're required to use Pascal's triangle in order to expand this. So let's just get a copy of the triangle here. So here's a copy of Pascal's triangle down to like the 7th or 8th row, depends on how you look at it. Let's call this the 0th row, because if we did a plus b to the 0 power, we would get 1, which is 1. And so we'll look at this in that way. So we know that this would be a plus b, or x plus y, because that's what we're doing. This would be x plus y to the first power, x plus y to the second power, and so forth and so on. So clearly this is the row that we're looking at to expand this. So if I'm dealing with x plus y to the 7th power, what I know is that the first term, x to the 7th, will be the first term. And so that will be 1x to the 7th plus 7. Look at me grabbing these coefficients rather. 7x to the 6y to the first power plus 21x to the fifth y to the second. Notice my x's decrease in terms of degree and my y's increase, always maintaining the degree of 7 for each of these terms. Let me keep it up. Plus 35x to the fourth y to the third plus 35 again, x to the third, y to the fourth, plus, I'm getting there, guys, 21x to the x to the second, y to the fifth, plus 7, oh, I can't make it, 7x to the first, y, ooh, let me get my pen back, y to the sixth, and finally 6 plus 1 y to the seventh. And that's not pretty. My hand is kind of giving me a little bit of trouble, so please forgive the extraordinarily extra sloppy handwriting, but I hope this made sense. And so you see how useful Pascal's triangle can be. Okay, so now we have the binomial theorem that we were talking about, that we Googled and we saw, and oh boy, does it look like a lot. You can kind of take a moment, take a look at it. If I'm taking a plus n to the nth power, the first term is going to be 1 times a to the n, and b to the 0, which is just 1. And the next term is going to be a to the n minus 1. We're seeing the decrease in the degree of the a variable and the increase of the b variable. The degree of the b variable, and that's fine. And then we can get the coefficients. This is kind of nice because we're not relying now on Pascal's triangle to get the coefficients. So there's something nice about this, but it looks rather complicated. N over 1, then n times n minus 1 over 1 times 2, then n times n minus 1 times n minus 2 over 1, 2, 3. And we can keep going and noticing the relationship between this exponent, n minus 3, the exponent of a, and how it relates to the coefficient. And so we can definitely explore that, and then we get an opportunity to explore it in a whole different way. And we're going to do something that kind of relates to this, but I'm going to write it slightly different. Okay, so this in essence is the same thing, but I feel like the way they wrote it is so much more clearer, and it makes me feel happy. So we're going to do it this way. So I don't want you to copy the other ones down. I'd like you to copy this down for the binomial theorem, and let's talk about what it means. So what we have is some new notation where you've got n and r, and so what this, we would read it as n choose r, and this is something that you use in in probability, and you would see it, and this would be a combination versus something else called a permutation. We can talk about that later. It'll be fine. But let's use this notation anyway, and it'll give us great practice for what's coming up. So basically, when you have the n and the r here, these two numbers, what it means is this. It means you take n factorial, the top number, the factorial of the top number, and you multiply it by the bottom number factorial. You divide it rather by the bottom number factorial, and then you continue to divide that by the difference between the top and the bottom number factorial. And it'll look better when we do an example. So we do n and 0, so n choose 0, n choose 1, n choose 2, all the way up to n choose n. For some reason, this just feels a little bit more satisfying to me. And basically, all of these will come out to be these little expressions here. Okay, and so what you can notice is that we have a sub n times b sub 0, a sub n minus 1. So you see the a decreasing and the b increasing, right? We see that, that's fine. But now this gives us the power to really get our coefficient. All we have to know is what term we're talking about. So if it's the first term, we use 0, n choose 0. If it's the second term, n choose 1. The third term, n choose 2. You guys are with me. All right, so this video is going to run out because I don't have more than 15 minutes, so I'm going to have to do a part 2. Don't cry. It's okay. I know. I don't like it either, but we'll get there. All right, I'll see you in the next video.